Welcome to myprojectbazaar.com. The project title is Generalized Code Index Modulation Technique for High Data Rate Communication Systems. The project abstract is: we propose a generalized code index modulation technique for direct sequence spread spectrum communication. At the transmitter, the bit stream is divided into blocks, in which each block is divided into two sub-blocks, mapped and modulated sub-blocks. At the receiver side, the spreading code index is first estimated, thus resulting in a direct estimation of mapped sub-blocks bits. The proposed modulation scheme can achieve a high data rate than the conventional DSSS systems, with lower energy consumption and complexity. The project flow diagram is to calculate the high data rate for code index modulation technique. Initially, we create an system model for modulation scheme. In this process, we use on frequency modulation, that is FM. In our process, using code index modulation for direct sequence spread spectrum, that means DSSS. Next, we analyze the SER, it means simple error rate for transmitting antenna. Next, we analyze the BER, it means bit error rate at transmitting site for AWGN, it means antenna waveguide propagation. Next, we calculate the energy efficiency for throughput and SNR. SNR means signal to noise ratio. Finally, we measure the performance for code index modulation for high data rate transmission. Our project source code file was run from the command window. In current folder shows the many files. In our source code file was stored from the main.m. So we have to run the main.m file. The process will be going on. After run our process, the workspace will show on. In that workspace, we have to check the variables values. It is up to minimum and maximum values are. We have to check our workspace values. In figure 1 shows that the analytical BER and simulation for CIM system with MPSK and PSK modulations. In that graph, we have to use the analytical BER and semi-analytical BER. It is the transmission line antennas. In X label shows that the EB by N0 and Y label shows that the BER. In figure 2 shows that the analytical BER and simulation for CIM system with MPSK and PSK modulations, where the analytical BER and semi-analytical BER transmitting from the AWGN antennas, where the SNR value is minus 10 dB. In X label shows that the EB by N0 and Y label shows that the BER. It is the graph for our CIM system with MPSK modulation. In figure 3 shows that the complexity comparison of proposed CIM. Our CIM system will show on the black color line and QPSK systems are shown in the red color line. When X label shows that the number of mapped bits per bench and Y label shows that the number of operations. In figure 5 shows that the complexity comparison of the proposed CIM. When the number of transmitted antenna is 2, the SNR value is minus 20 means that line will be like that. In X label shows that the number of mapped bits per branch and Y label shows that the number of operations. It is the proposed CIM. In figure 6 shows that the complexity comparison of the proposed CIM, where the number of antennas and receivers will be increased, the SNR values also increase. Our proposed CIM method is shown on the red color. In X label shows that the number of mapped bits per branch, and Y label shows that the number of operations. In figure 7 shows that the QPSK with antenna waveguide propagations. In X label shows that the signal to noise ratio, and Y label shows that the bit error rate. Our proposed SCR value will be shown on black color line, where proposed CM values are n equal to 2 and capital N equal to 1. Like that values are changing according to that value, the graph also varying. In figure 8 shows that the performance comparison of our proposed CIM and the SM systems. Our SM transmission will be shown on blue color arrow line. In our proposed CIM method are shown in the black color line and blue color line. In X label shows the EB by N0 and Y label shows that the BER. In figure 9 shows the our mapped bits and transmitted bits to calculate our bit error rate. It is the 3D graph of our final data rate comparison graph. Our project demo was completed. Thanks to watching this video.